All right, here are solutions for perfect problem 2 from Math 213. Pretty challenging problem, but let's kind of work our way through it. So the basic idea is if you're just drawing two lines in a plane, either they're parallel or they're not. And if they're not, they intersect. You have 1 point of intersection. If not, you have 0. So you kind of have this 0 case and this 1 case here. But the question, or one question, is asking what if there are 3 lines? Could you still have 0 points of intersection? Well, sure, just have 3 parallel lines. And I'm not going to draw the arrows on the end of these just because I'm a little bit lazy, but some picture something like this would do the trick. Could you still have 1? Well, sure, you could have all 3 of those lines kind of intersect at the exact same spot. So you get a picture that looks something like this. What about 2? Would it be possible to have exactly 2 points of intersection? Well, yeah, and there's a couple of ways you can get there. I think the easiest way is to think about this case that used to have 0 points of intersection and draw a line that intersects both of them. So start out with 2 parallel lines and then draw a line that intersects both of them. So you get 1 point here and another point here. You also could have gotten there by starting with this picture where you have exactly 1 point of intersection and then introducing a parallel line to one of these 2 lines. Essentially, it would, well, I'll call that good. That's 2. What about 3? Yes, it turns out you can get 3, and you can kind of just draw lines at random to figure it out. Although I think it's easier to start with a picture you already have. So I like starting with this kind of X picture here. And then if I want 3 points of intersection, I already have 1, so I need to add 2 more. How can I add 2 more? Well, I could draw a line that would intersect each of those 2 lines that I currently have. And it's worth noting that I couldn't get any more than 3. The maximum I could get up here would be 1. And the maximum I could add would be 2, because the new line that I draw only has 2 lines that it can intersect. So I can only add 2 more points, I'd get 3 right here. So that gets me through the first of these problems. Unfortunately, there's many, many, many more, but let's see if we can get through them. So what if there were 4 lines? Well, sure, you still have this easy, well, not that easy, 0 case where all 4 lines are parallel, which is surprisingly hard for me to draw on my computer. 1, 2, 3, 4, fine. And you could still get 1, no problem. Those you kind of always are going to get for free. Just draw 4 lines that all intersect at the exact same point. But could you get 2? I don't think you can. That might be surprising that you cannot get 2. But sort of think about where 2 would come from. Well, if I started with this case right here, and I added a line, it would intersect 1, 2, 3 spots. So I'd kind of have too many automatically. What if I started with this case? I mean, if I put a line in that's parallel to any of these guys, it's parallel to all of them, and I'm in the 0 case. So what about 1? Well, my only options are I could draw a line that goes right through the point I already have. Oh, that's this guy. I could draw a line parallel to any of the lines I currently have, but that would add 2 more points of intersection, so I'd be all the way up at 3 already. So I don't think 2 is possible. Maybe I'll write that. 2, not possible? What about 3? Well, we've talked about how you could do 3. I think the easiest way to do it is to start out with 3 parallel lines and then draw a guy that intersects those guys. 1, 2, 3. What about 4? Well, let's see. You got a few options in terms of how you come up with 4. I think the easiest way to do it is to start with this picture of 2 and think about how you could add 2 points of intersection to that. So let me try to draw that picture that I already had for 2. It looks something like this. Could I add exactly 2 points of intersection to this guy? Well, sure. I could draw a line that's parallel to this guy. If I draw it parallel to one of these guys, it's only going to add 1 point of intersection. But if I draw it parallel to this guy, I'll add 2 more. And now I got 4. Is that the most you can get? Well, no, it's not, because you could get 5. How could you get 5? Well, a few ways. One way would be start with our 2 picture and draw a line that adds 3 intersections. That's not too hard. Here's our 2 picture. 1, 2. And draw a line that adds 3 points of intersection. Well, as long as it's not parallel to any of the current lines I have, since there were 3 lines out there, it would add 3 points of intersection. 1, 2, 3, 4, 5. There's 5. What about 6? I'm going to use similar logic to what I did to find 5 and say, well, if I drew a line, the most I can add to any of these pictures is 3. And the way I could add 3 is by drawing a line that's not parallel to any of them. And the most I could have up here would be 3. So I could take this picture of 3, which I will try my best to recreate. So I have these 3 points of intersection. And now all I have to do is draw a line that's not parallel to any of them. And it should intersect each of the 3 lines exactly one time. So this guy, for example, will do the trick. And we'll add 1, 2, 3. So note I took my maximum up here and I added 3 more to get my maximum down here. The maximum I could add to this, which had 3, was 3 more because there's only 3 lines here. Just like the maximum that I could add to this was 2 because there were only 2 lines here. You can kind of look ahead and figure out what's the maximum you could add here. Well, I think I'll be able to add 4 lines to this. I'll be able to get 10 total. And the way I'll do that, maybe I'll go ahead and jump ahead, write that now. The way I could add 10 would be to add 4 to this picture. It's not the prettiest picture in the world, but let's see if I can recreate it. There's 1 line, and then, well, let's see. I guess I started out with something that looked kind of like this triangle. And then I added this guy in here. And so what I now have is 1, 2, 3, 4, 5, 6. So here's a recreation of this picture. My claim is that I can add 4 more points of intersection. And the way I'll do it is just draw a line that's not parallel to any of these guys. So I don't know. Let's see. How can I do this without, well, keeping it easy to read? Any line will do. Any line that's not parallel to these guys will do. But I'd like the points of intersection to be visible. So let's draw it like this. Extend this line a little bit. There's 1 new point of intersection. There's a second new point of intersection. There's a third. And had this line been extended a little bit, there's my 4th. So there's the case for 10. I kind of jumped ahead, but that'll be the maximum. Could I still get 0? Well, yeah, of course you could. Just 5 parallel lines. 1, 2, 3, 4, 5. Could I still get 1? Sure. 1, 2, 3, 4, 5. Those are kind of boring cases. What about 2? I don't think you'll be able to get 2. And here's my logic. To get 2, you would have had to start with a picture that had 2 or less, so one of these 3 pictures. If you draw a line that's not parallel to any of these guys, you're all the way up to 4. If you draw a line here, you're going to add 3 more, so you're up to 4. So I don't think it's possible to end up with 2 or 3. 2 and 3 are not possible. But I think you can get 4, and we've already kind of talked about how you could do that. One way you could do it is to start with this case and draw a line that's not parallel. That'll add in 1, 2, 3, 4 points of intersection. What about 5? Well, one way you could get to 5 is start with this picture here. So note that this picture here had 1 point of intersection. Could I add 4 to this? Well, sure, there's 4 lines up here. So draw a line that's not parallel to any of those 4 lines, and you'll add 4 points of intersection. So here's my starting spot. Not the greatest picture in the world. And draw a line that's not parallel to any of those guys. I don't know. How about this guy? 1, 2, 3, 4. There's 4 new points. 1, 2, 3, 4. And that's my 5 case. That's one possible 5 case. What about my 6 case? Well, I could add 4. Let's see, I could add 3 to this picture. That might be the easiest way to do it. So for my 6 case, let's start out with 3 parallel lines. And then draw 2 parallel lines. That gives me 6 points of intersection. All right, what about my 7 case? Maybe that goes down here. Let's see, my 7 case, I'd like to add 4 points of intersection to this guy. So that's certainly doable because I could start out with 3 parallel lines and a line that passes through them. They don't need to be perpendicular, although they appear to be so in this picture. And so I have 4 lines here. So I want to create 4 new points of intersection. Just draw a line that's not parallel to any of the 4 I currently have. That'll do. 1, 2, 3, 4. There's my 7 case. What about my 8 case? Well, I think that one way we could get there is by starting with our 4 case. So that was 2 sets of parallel lines. I have 4 lines up here. So if I draw a line that's not parallel to any of these 4, it should intersect all of these points and leave me with my 8 case. So how about this line? 1, 2, 3, 4. And I guess I should have been a little bit more careful when I'm not just does it have to not be parallel to any of the given lines, but it also has to not go through any of the current points of intersection. I don't want to reuse any there. So I've been speaking a little loosely there. All right, and just one more to draw, then I'll finally be done with all these pictures. 9. Well, what's the easiest way to do it? How about I take advantage of this picture? I draw something very similar to this. I just kind of scoot a line over a little bit. So maybe I take, well, maybe that's not a good idea. Okay, so how can I get 9? Let's add 4 points of intersection to this picture right here. So this picture started out with 2 lines that were parallel, and then 2 lines that went through them. Let's see if I've redrawn that picture correctly. Oh, and 1, 2, 3, 4, 5. Good, that is what I wanted. 1, 2, 3, 4, 5. And then I want to add 4 points of intersection. So as I've been saying, just draw a line that's not parallel to any of these lines. That doesn't go through any current intersection. So 1, 2, 3, that's almost a straight line. Pretend it was. That would give me 1, 2, 3, 4 new points of intersection. I'd have 9 total. Wow. Okay, that's a lot of drawing lines. Let's move on to part 2 here. Complete this table. Well, the good thing about this table is a lot of it is easy. What's the smallest number of intersections possible? Well, you can always just draw your lines parallel. No matter how many lines you're drawing, draw them parallel. You'll have no points of intersection. You can fill in a lot of this chart with zeros. But what about the greatest number of intersections possible? Well, if you kind of think about how I created these, it might make this easier. First off, if you only have one line, it can't intersect anything. And if you have 2 lines, it can only intersect in one spot. But what about 3 lines? Well, when I had 3 lines here, what I did is I took my maximum number of intersections up here, which was 1, and I drew a line that went through each of these 2 lines. So I took the 1 and I added 2. I took the 1 and I added 2 to get 3 over here. That was this picture. Well, what about this picture? I know the answer is 6, so there should be a 6 right here. But instead of just writing a 6, I'm going to think about it like I had these 3, and I added 3 more. Why 3 more? Because there's 3 lines up here that I can intersect. So I had these 3, which were really a 1 and a 2, and I added 3 more to that. What about down here? Well, the answer was 10, but where that 10 came from was the 6 that already existed here, plus 4 more. So it's the 6 that I already expressed as 1 plus 2 plus 3, plus 4 more to get this 10. And maybe now you can kind of see a pattern going on here. If there were 6, I could add 5 more to get 15. If there were 7, I could add 6 more to get 21. If there were 8, I could take this picture, draw a line that isn't parallel, doesn't intersect at the same spot. I could get 7 more, get up to 28. 9, I could get 8 more, which would be 36. 10, I could get 9 more, which would be 45. Really what's going on here is in the n case, I have however many I had in the n minus 1 case, plus n minus 1 more. So if you think about this 45 right here, it's really 1 plus 2 plus 3 all the way up to 9. I didn't want to list them all out, but that's where this 45 came from. So what about n? Well, n would just be 1 plus 2 plus 3 all the way up to n minus 1. Right? Up here in the 10 case, I stopped at 9. So in the n case, I would stop at n minus 1. Okay, so how many lines do I have when I add these all up? Well, it turns out that you have n times n minus 1 divided by 2. And where that comes from is Gauss's method. So maybe I'll put a little arrow here and say this is Gauss's method. I take this sum, 1 plus 2 plus 3 plus, all the way up to n minus 1, and I write it again, but in descending order. So the biggest number, n minus 1, the second biggest number, and so on, all the way until I get down to 1. And what ends up happening is if I sum every column, 1 plus n minus 1 is just n. 2 plus n minus 2 is n. Every single column sums to n. So I get n minus 1 columns, each summing to n. So in total here, I have n minus 1 times n. But I don't want this total here because I wrote my sum 2 times. I have to cut that in half to get this answer right here. And now that you have this formula, you can figure out what n must have been to give me 136. You can do it algebraically. I don't recommend it, but you can. I think it's probably easier to kind of guess and check your way to this. So 10 gave me 45, so I'm going to need a number bigger than 10 if I want 136. What number should I use? I don't know. Let's try 20. If n were 20, the total number of intersections I could have at maximum would be n, 20, times n minus 1, 19, divided by 2. And that gives me 190. Oh, too many. All right, so let's go down a little bit. Maybe 18 for n. Then n minus 1 will be 17. Divide that by 2. And I get 153. Still a little bit too high. What about 16? What about 17? What about, yeah, whatever. 17 times 16 divided by 2. That one worked, 136. Yeah, cool. So 17 is the magic solution here. What about 780? Well, I'm going to need a number that's significantly bigger to get 780. Maybe I try, I don't know, 25. Sure. 25, n minus 1 will be 24 divided by 2, and you get 300. Oh, that's not even close. All right, what about 40? 40 times 39 divided by 2. 780. Hey, I'm a great guesser. I got that in just 2 guesses. There's a 40 right there. What about 2,701? I don't know. That's huge. I'll have to probably get a really big number. Let's try 80 for n. Multiply it by 79 and divide it by 2. That gives me 3,000. Oh, actually too high. So I want less than that. How much less? I don't know, maybe 75 times 74 divided by 2. And I get 2775. Oh, pretty close. Not quite what I wanted, but really close. What about 74 times 73 divided by 2? Hey, look at that, 2701. So that means n is equal to 74 here. Is it possible to draw 7 lines in a plane in such a way that there are 6 points at which 3 lines intersect and 4 points at which 2 lines intersect? If so, show how it can be done. If not, explain why not. Okay, so it turns out that this is not possible. If not, explain why. Oh, a couple extra lines thrown in there. It is not possible. And there's probably a more clever way to show why it's not possible. One way you could is kind of going back to what I guess Math 211, one of our problem-solving methods, was to make a systematic list. And so what I'm going to do is I'm going to name my lines. And so what do I got? 6 of them. There are 6 points, no, 7 lines. So A, B, C, D, E, F, and G. These are my lines. So lines A, B, and C could intersect, for example. So maybe these are intersections. Maybe I need more room. So suppose you could put the lines in such a way that A, B, and C intersect. So what I'm going to try to do is come up with 6 points at which 3 lines intersect. So 1 point of intersection is where A, B, and C intersect. Note that I could not now write A, B, D, because A and B only intersect in one spot at most. And that spot, C is already intersecting with them. So I can't put A, B, D. In fact, I can't use any 2 of these 3 in another pair. So I could use A again, but I couldn't have a B or a C in here. So I guess maybe I'd need a D and then maybe an E. Sure. Then I could use A again, but then I would need an F and a G. And I guess that's fine. So far I got my lines in a way that they intersect like this. I don't think I can use A anymore because I've now used A with every other letter. So let's go to B. Well, B can't go with A because it already has, or with C because it already has. But it could go with D. But note it can't now go with E because D and E have already been together. So now maybe I say BDF. Sure. BDF would be a perfectly good combination. Okay, I can't do B and D again. I already said I can't use B and A or B and C, so maybe B and E. BE, well, let's see, I can't do BEF because B and F have already been together, but BE and G I could do. What about C's? Well, C's have already been with A's and B's, so that can't happen, so I throw a C down. And then what should I put that with? Well, C hasn't been with anything except for A and B so far, so maybe I could have it go with a D. Oh, D's already been with E, so I better not throw that on there. And D has already been with F, so I better not throw that on there. So maybe I'll throw on a G. And I think what you'll find is this is all of the possibilities. There's no more that I can put here for three-way intersections. So what about the intersection of two lines? Well, I can't do A and B because I've already had A and B intersect, and C intersects there too. Oh, A and D, or sorry, A and C, nope. A and D, nope. A and E, nope. A and F, nope. A and G, nope. So I can't have A intersect with any of the other lines because I've already taken care of all of those. What about B's? Well, I don't need to look at B and A because I already considered that case when we talked about A and B. So I'll start with C. B and C. Would that work? Nope, right here, B and C already intersected. What about B and D? Nope, already intersected here. B and E? Nope. B and F? Nope. B and G? Nope, that ain't going to work either. So nothing I can do with B's. What about C's? C and D? Nope. C and E? Oh, that might work. C and E. Do I have C and E in any of these triplets so far? I don't think that I do. Okay, so I have the first one on my list over here, C and E. What about C and F? I think that one might work as well. Any of these have a C and an F in them? Sure doesn't look like it. C and F. C and G? Nope. Okay, what about D's? D and E? Nope. D and F? See a D and nope. Doesn't work right here. D and G? Nope. What about E's? E and F? I think that works. I don't see an E and F together in any of these guys. I'm one away. If I could just find one more double here, I'd be done. Let's see. E and G, is that going to work? Nope. Bummer right here. What about F and G? If F and G work, my solution works. If not, that's my last possibility. Nope, it doesn't work right here. So it ain't going to work, right? Can you list them in such a way that there are 6 points at which 3 lines intersect? Sure, it could intersect like this. And 4 points at which 2 lines intersect? Nope, I can only find 3. Not possible. I don't know. I guess my explanation that I've talked about will hopefully suffice as a solution.